My name is Doug Holmboe. I work for Clurig Analytics. We do mostly social network analysis and text mining. That's our thing. This talk will be about an easy and quick way to create automated workflows using R and R libraries. And we'll talk quite a bit about the R libraries. The libraries, first of all, we're going to talk a lot about the different libraries, but very, very high level. The key here is to use different libraries to create workflows. And we'll talk about how we can access Google Analytics, how we can access Twitter, WordNet, which is a lexical database coming out of Princeton University, different ways to transform data, using different libraries for analysis, and then the final output in different types of ways. In order to run through this, we will pretend that we are a company and we build employee time clocks. And employee time clocks can be biometrics, where you put your hand on there. It clocks when you as an employee, you come into an office, you leave the office, or it might be a secure area that you walk in and out of. It might be that you type in a PIN code. Somehow it registers when you're walking in and out. In our case here, so that's a company. In our case here, we're looking to increase the hits on our websites. And we're going to use SEO to raise the search ranking. Currently, we have Google Analytics installed on our website, so we can see what's going on the website. We can also see the keywords that people are using in order to access or search for our website. The idea that we're going to try to do here is try to find additional keywords that we can use that triggers then higher search rankings. And in order to do that, we need to come up with different ways that we can find these keywords that are similar to keywords that Google Analytics are telling us. And we're going to try to do that using a linguistic database against WordNet. And we will also use crowdsourcing in this way, in this case, Twitter. And we will take that in, and we will do some reporting, tables, some interactive graphics on it. And then in the end, some weekly automated workflow. We will set up that one so we can set it up for automation. And that way there, the program will run through all these different phases automatically. We don't need to go in there and do this by hand. So the first thing we will do is we will have the automated workflow, the programs we will build. We'll go out to Google Analytics. It will access the keywords from Google Analytics, and we'll do some analysis on it. And we'll pick out the 20 most used keywords that Google Analytics gives us. The next thing we will do is for each of these top 20 keywords, we will go out to WordNet. Again, it's a lexical database. And for each of the 20 Google keywords, we will then get synonyms from WordNet. And that way there we can now say we have like keywords or like terms based upon what experts are saying are synonyms. And then we will go to Twitter, and we will do the same thing for each of the different keywords that we get from Google Analytics. We will perform a Twitter search. And for each of these Twitter searches we get back, we will search for 500 tweets each. We will do a number of different types of analysis, high-frequency keywords, correlations, association rules, and also bigrams, in order to find words that are similar to the words that people used in the first place using Google Analytics. So now we will have that. We will go in and analyze that, and then do some visualization in the end of it. So the first thing we'll do using a Google Analytics package called RGA. And all we need to do there is just open up an instance with it to the Google Analytics, to the session that we have over there. Google Analytics will give us a code that we need to type in, and then we have full access there. And using this library here, we will create a call called just a GA3, GA1 for get data. And the key points here, you can give it a start date, and instead of just a regular date, we can actually give it X number of days in the past. To today, we are looking specifically for keywords. That's a dimension. In this case here, we're also looking for city and date. We don't really need to. And then the final part is that in this call, we can do some filtering on it. And in this case here, we're only interested in real keywords. So we filter out keywords where it says not provided or not set. And we launch that search into Google Analytics. Based upon the data that we get back, so the last library used was RGA. In this case here, we use a text mining library called TM. probably one of the most popular text mining libraries in the R libraries. And in there, first we do some, just basically cleaning up the words a little bit. Using the text mining library, specifically in this case here, we're using the stop words, because text mining contains a lot of stop words. Stop words are similar to words that have no real meaning, like the word a, the, in, is, and so on. So we get rid of all of those. We get rid of a couple of more ones. And then based upon that, we simply just take the top keywords, or we do a high frequency on the keywords that we get from Google Analytics. High frequency in this case here, we just measure out the different words that are used the most. And we can now graph that. The graphing package we will use for this is just a ggvis, is one of the newer packages. And one thing I would like just to point out with this code here, we're also using a packet called Magator, not 100% sure how to pronounce it, which gives the pipe type way of doing things. Instead of wrapping a lot of functions within each other, we can just say the data frame, in this case here called X, pipe that into the ggvis for frequencies, and pipe that into layer different points, and pipe that up to, give some meaning to the axis. And the data structure we're using right now is just this one that we have up here. And that will produce a simple frequency graph, where we can see that time, attendance, employee, and clock, and so on are the top used keywords, which makes sense, because remember, we're a company that sells employee time clocks. So people are searching for those. That's what comes in on the Google keywords. We can also see that it has a very, very standard, almost like a power law shaped curve to it. So we know that what the data that we're getting back is probably similar, reasonably correct. The power law curve usually means that it's a few words are used a lot, and there's a lot of words that are used quite a bit in this case here. So things seem to be making sense. So what we did, just a little bit of a wrap up of what we just did here, we got words from Google Analytics, the keywords that people are using the most, and we then ranked them 1 through 20, or top 20 keywords. We did some visualization on it. The second thing we will do is now, for each of these keywords that we found, we will go out to WordNet and get a list of synonyms. And in order to do that, you use another packet. Again, there's a lot of packages here. Use a package called WordNet. And it's a very simple package. All we need to do is just take the Google Analytics keywords for each of the top 20 words, go out and get synonyms, and we put that into a data frame. And the data frame, after some parsing and cleaning up and so on, basically looks like this. Here are the different Google keywords, and here are the different synonyms. And we should also know that the keywords, keywords are obviously Google keywords, synonyms, but for each of the keywords that we send to WordNet for a synonym, it can be 0 synonyms to it, it can be 1, or it can be more than 1. So for instance, for time, we see that the WordNet gives us back clock time, fourth dimension, system has a couple of different ones, access has a couple of different ones, and so on. So this is now the Princeton University Lexical Graph database that gives us back this data. So that's part 1. What we just did here, we got data back, the synonyms back from WordNet. Now we're going to go over to Twitter. And Twitter, yet another library. Twitter R is probably the most used library for using the Twitter API. And as a little side note here, the Twitter API, the guys over at Twitter has done a magnificent job with that API. It's extremely easy to use. And it's then the layer with the Twitter R on top of that makes it super, super easy to use. So in this case here, for each of the 20 different words from Twitter, we're going to take each of, or from Google Analytics, I should say, we should take each of these keywords from Google Analytics, and we will go out and launch a search into Twitter, which we do here, and we search for 500 different tweets. We do some cleaning, and the cleaning is basically has to do with getting rid of some odd characters, changing the dates a little bit, and do some other cleaning going on in there. And so we do that for each of the Google keywords. We search for it, clean it, and then we put it into what I consider here a tweet list, just one entry into the list for each of these 500 tweets. Yes?
The Google keywords or the WordNet synonyms?
The Google keywords.
Okay.
So we took the WordNet synonyms and we put those aside.
Okay.
Now we're working on, again, back to the Google keywords because we want to find, the WordNet had to do with what the experts are saying, if you want, of what are like words. Now we're trying to see what the crowd, Twitter in this case here, are saying are similar words. And here are just different tweets containing the term work. Just a couple of different examples of tweets that we get back. And based upon the data that we get back from Twitter, here's just 3 different graphs that we can fairly quickly generate just using different libraries. One is the top users of people searching for the word employee, the top keywords, and obviously if you search for the word employee, the top keyword you get back is employee. In this case here, we see 470 instances of that, but we actually searched for 500 tweets. We should see 500. But on the other hand, we also did in the cleanup, we cleaned out a bunch of tweets that didn't make sense to what we were looking for. The beauty using Twitter is that we can throw out as much data as we want. There's still enough data to last for a long time. Then the last graph is basically the same graph as the other one, just showing another library called wordcloud, which is a great library for creating word clouds. In terms of the word employee, this is obviously more of a sample example. If this was a real thing that we were doing for a company, we would then filter out the word for as employee, because searching for the word employee doesn't really give any meaning. It's more like a stop word than anything. So now we got the data from Twitter. The second thing we need to do with the data from Twitter is actually do a Twitter analysis on each of them. And we will do 4 of them. We will do a high frequency, similar to what we did with Google Analytics. Basically, just take for each of the Google Analytics keywords, for the chunk of tweets that we got from there, we will analyze that, try to find the top words that are used for each of the Google keywords. The second we will do is something called correlation. We will try to correlate between the Google keyword and the other words in that number of tweets. The third one is association rules, or it's called the market basket rules. I'm going to go into that later. And the last one is using n-grams or bigrams in our case. The first thing we need to do before we do anything is, again, go back to the library called TM. We need to create a term document matrix. And we will do that by taking all the different tweets for a particular keyword. The text row is actually the 500 pieces of tweets per keyword. We get rid of stuff that we don't need, URLs, stop words, punctuation numbers, and so on. We make everything into lower. And then based upon this corpus, we now create a term document matrix. And a term document matrix is basically just a simple matrix. However, for each of the word, what we do here has rows. Each word has its own row, and it can be any number of rows depending on the total number of words in this corpus. And each of these columns here is a document, or in our case, it's actually a tweet. So we can see that, for instance, the word acceptable was not located in tweet number 1. It existed in tweet number 2, existed in tweet number 4, and in number 7. So that way there we have a total matrix of all the words total and all the tweets total as well. And one side note here we can look at, we see 2 tweets that have basically the same words, abomination, abuse, and access, does not have acceptable. Maybe that's a retweet. So now we have all the words, again, 1 TDM for each of the Google keywords. The next one here is fairly simple. We basically just take and calculate the top frequency words. And simple as we do here, we just take the TDM, convert it over into a matrix, and then we do a row sum. And remember, every row was a word. And if we sum all the instances of that word, we know how many words there were. We know how many times this word existed in all the documents together. And we sort that, and in decreasing order. And we take the, in this case here, the top 20 of those. And now we have another data frame. After some cleaning and so on, we have the Google keywords. And then per Google keywords, we have the high frequency keyword, and obviously employee comes up first. Union, government, I'm not really sure what the PTV is, but then the list continues. And this now is the same list as we saw on the previous slide. So that's a high frequency. The next one is find associations. And again, the TM package actually gives us a function called find assocs. And what it does is that if you think about a term document matrix, each row is a word. And each row then has a 0 or a 1 for each of the words or for each of the documents that's being used. That's, in essence, a stream of data. So if you take two words, you can now do correlation between them, see if they are correlated or not correlated, meaning that if the words exist in many of the same different documents, together with, in this case here, the employee, we can now say that they are correlated. And what we can do is, as David was saying in his speech, correlation goes from -1 to 1. And in our case here, we're looking for correlations higher than 0.4, because we see that there's a reasonably strong correlation. Usually a strong correlation is from 0.75 and up. Correlation is 0.25 and up. That's sort of in the middle. So it's a reasonably strong correlation. And again, the TM package just gives us that directly. And now we can see that based upon the Google keywords, what the crowd has been saying, or Twitter has been saying, is that the word social correlates together with the word employee, or advocacy, complain, friend, supervisor. And so all of these words, as we can see, actually make sense. It's not like we see weird word like employee, Boston Red Sox or something like that. It's actually really makes sense. The next one is association rules. And we use a package here called the arules. And we use a TM package, again, because we actually internally create a little bit different type of term document matrix. But basically association rules, those called market basket rules. And that is similar to when you go to the checkout counter. And the idea here is that if you buy milk and you buy bread, most likely you're going to buy butter as well. These type of associations, that's why it's called market basket rules. In our case, we're saying, what are the chances here if someone types in the word employee, that they also will type in the word government? And in this case here, we can see that it's pretty high. And same thing with type in employee, employee, and employee union, and so on. So again, this is now a third different way of analyzing Twitter, but they sort of all point to the same thing. And the last one is n-grams, or in our case here is bigrams. And we use a library called RWeka, and it actually depends on another library called rJava, so we can connect into Java through R. And rJava is obviously used quite a bit, and it's a pain to install for you who are interested in doing that. Anyway, so what RWeka does is that we're going to create a TDM again, like we did before. However, for each of the Google keywords, we will actually use RWeka to call this function here, which says that in this case here, we want to create, instead of creating a TDM with just one word, we will create TDMs with 2 words. So that's why I put in minimum 2 words, but also maximum 2 words. So at the end of the day, we get a term document matrix that we call based upon the same corpus as before, but tokenize it using this tokenizer function that we created up here. And that way there, we can now get a term document matrix that has 4 rows, 2 words, and where these 2 words are stored in each of the different documents. And the key, I think the main difference between association rules and n-grams is that in association rules, order does not matter. For instance, if you buy milk or bread and butter, it's different from buying bread and milk and butter, for instance. In this case here, the order of is actually important. And anyway, so we can see here, though, that the word employee, what people typing in is government employee, employee union, contract negotiation, negotiation contracts, and so on. So again, we get words that seems to be making sense. So now we have the data from Google Analytics. Based upon that, we went out to WordNet, got synonyms, we went to Twitter, got a bunch of tweets here. We did a bunch of different analysis of 4 different analyses. And then we're going to combine that into one major analysis, which I actually will not go through in detail here, just mention that there are a number of different libraries for data wrangling that people are using. And that is a stringer, which simply just makes dealing with strings a little bit easier in R. Plier, some people stay with the apply, s apply, and l apply, or you can use the plier. Reshape is something that we use quite a bit in here, where you can melt and cast. Basically, you can transform data structures into different things. A newer library that I mentioned before, Migrator, or my pronunciation is probably not perfect, that gets Unix-like pipes. And for those of us who grew up on Unix and then Linux, this is probably the most wonderful thing that's ever happened to R. And then we have Lubridate, which makes dealing with dates a little easier. Yesterday, during the R boot camp, John was talking about the basic pain in the neck of using date as data, the date functions there, or the POSIX CT and POSIX LT. The Lubridate simplifies quite a bit of just dealing with dates in general. The data structures that we finally get is a data structure that looks like this in this case here, where here we have all the Google keywords that we got from Google Keywords, all the synonyms, and obviously we didn't get any for any of those keywords here. The synonyms that we got from WordNet, the like words, if you want to call them that, from high frequency analysis of Twitter data, correlations, n-grams, and from association rules, and then the count as well. And I think probably the two more important here is point out the word just. Again, if this was a real thing, we probably just filter that one out because it has no meaning whatsoever. However, another one is important is that the word ticking goes together, is associated with the word clock, and it's done that in 3 different places, which again makes sense when you think about it. You know, clicking clock, right? Ticking clock. And then at the end here is just a simple count of a number of times these words are being used. If I understand right, the word attendance and LSU, I guess it was a football game the day that I was doing this. Again, in real life, that would be thrown out as well. Then the last part here is visualization of the data. And the first thing we will do is to look at just using ggvis, yet another library. It's actually a great library as well, for showing how we can visualize the data, but in a table format. And here's a code, just a very, very simple code. And here's how we can plot it. Or in my case, what I did here, I just took the data out of table 2 here and carried it into a ggvis document. What you will see, though, is that when you try to display this data in a table format, you will see that there's very sparse data. So there's a lot of empty space. So it's a little bit tough to see the insights, but we're going to look at that anyway. And I will do that here. And so now you can see. So for instance, I can sort this by Google keyword. I can go in and look at, see which keywords, Google keywords, are then synonymous with WordNet. So I can just sort on WordNet. I can do the same thing with high frequency keyword. For instance, time goes together with year-old, employee with work, and so on. Makes sense. The other analysis with correlation, exotrend, not really sure what it is, but employee, work, time, wine. I don't know if you wait for wine to be good or something like that. And so on and so on. But again, this one is good for when you just want to look at these kind of things, but it doesn't give you a total overview of what you're looking for. So instead what we'll do, which going to use a different library called igraph, and it's more of a social network analysis graphing library. And in my world here, dealing with social network analysis and text mining, this is just a total fabulous library here. And again, we take the use a melt function that we got from Reshape 2 by RWeka and shape the data into something that looks like this, where we have the Google keyword. In this case here, I just call it source. It's not really a source, it's more the source/algorithm. The source is WordNet. The source for these two are Twitter, but there's 2 different algorithms, so I just call it source for the sake of it. And I call it just like word. So what we have here is 3 different groups of data. So Google keywords, one data. The like word is another piece of data, and where that like word came from is a third piece of data. And so we create this data structure, and then based upon that, we create a graph out of it using the igraph. And we can create it as a directed graph. In our case here, we don't need it, so we create it as an undirected graph. And we store it in this variable g. And then based upon the this graph, v is for vectors and e for edges and so on, you can now set the different colors. You can set different sizes based upon how you want to do that. And then you can then either plot it or doing an interactive plot. I will try to see if I can get an interactive plot up on the screen, because that is a little bit more interesting to see. And it will look a little bit messy as you look at it here, because this is a really tiny screen, which obviously I can make bigger, so it will become less messy. But what you can see here, though, is if I can grab this one here, it's interactive, meaning you can pull things out a little bit. And obviously there's a lot of data here, but the red are the Google keywords. So in this case here, we can see that the employee, first of all, has a size that is bigger. So now we can say that employee is probably the most used keywords after we've done all this analysis and so on, but until we get here, that people are typing in Google Analytics. We can look at what I consider sources here. And again, they have different sizes based upon how many edges they have. Or in the graphing world, we call them degrees. So you have in degrees and out degrees if it's a directed graph. In degrees are people linking to you, out degrees what you are linking out. In this case here, they're just degrees because it's an undirected graph. So anyway, so we can look at this, and it makes it a little bit easier to see, because compared to the table that we use with ggvis, because we don't have any sparse data, this is actually real data that people are using. Having that one in mind, we might say, okay, I would like to drill in to just one of these words, because again, it's still a little bit overly done, or too much data, I should say. And so we can fit this to screen again. And suddenly now we can see it a little bit differently. And again, it's interactive, so we can move things around, which might be useful because we might want to move this one around, and we see that job has to do with both high frequency and association rules. The word click, again, is a little bit bigger, correlations and high frequency, meaning that they are used a little bit more. Also, what we can see here, when we just use once, we can see the different clusters of like words, if you want, that goes together with the n-grams. Same thing as another cluster here for WordNet, sort of what the experts are saying are similar word or synonymous with the word access. Correlations, a little bit of a cluster, and association rules obviously have just one connection there. On the other hand, the word job has two connections, or two sources, I should say. So that's one interactive graph. The next one is going to show, and more just want to show for the sake of showing than anything, but it's one of these interactive force graphs. And again, it's a fairly simple interface. You just take take a data structure, same or similar, probably did some manipulation on the previous one, but similar data structure as we had before, and call this. And by the way, here's the data structure. It's just the source and the target in this case. So I simplified it up a little bit. And it will look like this. And I will refresh it so we can see how it pops up on the screen. And it's, it's not super useful in all honesty. It's fun that you can shake it. And you can click on things so you can see the different ways. But sometimes you don't find things. Like, for instance, association rules is just off the screen. It's down there, but when I left it, it sort of goes away. Anyway, so it's a fun graph. I think what's neat with this thing here, though, is again that you fairly simply can see the different clusters. And that is one place where it makes good. But apart from that, it's more a fun thing. If you've got nothing to do, you can sit there and shake the cursor. Then the this is now the last graph I will show you. It's from rCharts, which is probably one of the first charts that was, or first package that was built as a bridge between the JavaScript, also these three libraries, and R. And the rCharts has a connection into a number of different these three libraries. And we will use one of them in this case here. And it creates a line with a focus chart. I'm going to see what that is. And it's, again, very simple, just two codes, and you have something, you store it into an HTML document. The database here is, or the data that we used. So this is, by the way, a little bit different data than from before. This is actually doing a Twitter analysis on it, but instead of doing the different network diagrams out of it, we just create a data structure with the dates coming down and the terms that were used during these different dates and a count here. And so that will look like this. And so what this is, we can now see that the different words up on top that were used at certain times during from August 31st up to September 11th. And this is interactive, and we can see that this word here, the top graph is software, and so most likely the word I used to search for this data was most likely software. I can click on this one here and the word software disappears. Down here, I can then select different areas. And this is sort of a standard graph here. But there was one thing, a little bit funny thing that I noticed, that if you look for only jobs, so this is not people sitting on Twitter talking about jobs. And as we can see here, this was 31st of August. Then we had Memorial Day, and obviously there's a lot of people talking about jobs. Slowly but surely, as a week go by, down to Friday or Saturday, no one talks about jobs anymore, right? And then suddenly it jumps up again, and Monday we start talking about jobs. So it seems like there's some sort of a curve here. But based upon David's point before, don't trust any of this data. It's just a small sample in time here. And who knows what I did in my analysis and so on. So what we did here, so we're in essence coming to a conclusion of this talk here. Just a little bit of a wrap up. So we got words from Google Analytics, the words that people actually type in, and we find that through Google Analytics, through the R package, RGA. Then we go out to WordNet, getting the synonyms based upon these words, again using another package called WordNet. We go down to Twitter for each of these Google keywords, grab 500 tweets, we do some analysis on it, use a number of different packages, TM packages for text mining, association rules, and so on. Take it in, do some analysis on it, and then visualize it in a couple of different ways. So that part is done. What we will not do in this case here is set up for weekly automated runs as part of the IT guys that can do that. And so that is done. And all of this is now just one project that can be run on a weekly basis, and then you can see what's going on. And now you can pick what you consider the best keywords for your web page in order to try to raise the search rankings. And again, the libraries that we actually used through this process were all of those. The only one that we actually did not look at is the XLSX library. And just a quick mention of that, because that's a library I just first time used just last week. And I didn't know how just absolutely super easy it is to create a workbook, create different pages or sheets in the workbook where you can store data, save the workbook, and now you have a full-fledged Excel spreadsheet with all the data that you want, that you can now share your data together with people who do not use R. And if you have many different types of data, normally you share data using CSV files. Using the XLSX library, you can now put all the data into one file and ship it out. Makes it super, super easy. And that is it for me. Any questions? Either I was that good or I was that bad. One question?
Yeah, actually, the percent, greater than symbol, percent symbol, that Unix term, I actually don't know that. But you need that library that you mentioned in order to use that?
Yes, you need the library, that Magiter library, however you pronounce it, yes. Okay. And it's a great, great thing, because instead of having a number of different functions, sort of collapsed on top of each other, makes it sort of impossible to read. Mm-hmm. Suddenly you can just read it. Okay, first I do this, and then I pipe the results from the output of that to the input of this.
Okay.
Do this, pipe the way over.
Okay, yeah, it seems much more readable.
It's super readable. There was actually one down there.
What about if you have raw data set that has spelling error? Is there a function that can help identify words that was spelled wrongly, but actually meant to be applied?
Using the pipe again for standard errors? I believe it only does, as far as I know, it only does for the standard output from that function. And I don't even know if it uses the Unix/Linux term standard error or standard in or standard out. It might use something else internally. But it's basically the output from one becomes the input from another.
How many weeks did it take you to find and learn all those libraries?
If I said that I knew every single library to detail, I'd be super lying here.
Well, enough to use them.
I can tell you that I actually did this project in a very simplified form about last year. And it was 2 hours from where sort of the idea popped in. And I knew how to use Twitter very well all the time. So, but from the idea that I could actually get Google keywords coming in, I'd never used that before. I'd never used WordNet before. I just knew there was a library, so download that one, and then do the Google, and then do the Twitter analysis. But I think I want to do one analysis, maybe the high frequencies, because it's really simple. And I knew that from before. And then put it out on a chart. I used a little bit different chart, but that was about a 2-hour time frame. Not because of me, but because it's actually really simple. I mean, when I say that's just a 1 line of code, it is 1 line of code. You just need to figure out which line of code. And I think you were, and I think you were here yesterday, right?
Yes.
And then you saw also using Stack Overflow.
Oh, yeah.
You just type it in whatever online search engine that you like, and you get examples. The key with those places, so you just need to figure out, again, what is the question I need to answer? And normally you ask the wrong question, but through the answers, you figure out the right answer or right question, and you get an answer, cut and paste, change a couple of things, and you're done, and you move on, right? It's almost like you don't need to learn anything, because all the examples, they just pull everything together. Okay. Well, thank you, everybody. Thank you very much.